So let's go ahead and do one more example, this time maybe using the, well, let's see what the example says. So example number 3, this says find the cosine of the angle between the surfaces x squared plus y squared plus z squared equals 38, and x, not x squared, minus z squared minus y squared equals minus 38 at the point minus 1. Let's make sure we write everything clearly. Minus 1, 1, and minus 6. Okay, we're starting to get these stray lines again, so I'm going to move on to the next page after I finish writing this. Okay, so find the cosine of the angle between the surfaces x squared plus y squared plus z squared equals 38, and x minus z squared minus y squared equals minus 38 at the point minus 1, 1, minus 6. So at that point, the two curves hit each other. We want to find the angle that the two curves make with each other, the two surfaces make with each other. Okay, so this is a good time to give a quick definition of what we mean by the angle between two surfaces. Okay, the angle between two surfaces the angle between two surfaces is defined as the angle between the normal vectors to the surfaces. At that point. And we know how to find the vector that is normal to a surface at that point. It's the gradient vector evaluated at that point. Well, that's the whole idea. You have a surface, the gradient vector is going to be perpendicular to that surface at that point. Very, very nice. Okay, so the angle between two surfaces, where the two surfaces is defined as the angle between the normal vectors to the surfaces. You have a surface, you've got a normal vector. You have another surface, you have another normal vector. You have two normal vectors, the angle between them, that's the angle between the surfaces. Nice and easy. Okay, so f of 1 equals x squared plus y squared plus z squared. Now, the gradient of f of 1 equals 2x, 2y, 2z, 2z. And when we evaluate at the particular point, we end up with minus 2, 2, and minus 12. So that's one of them. Now, the gradient of f of 2. So this vector is normal to the surface at the particular point we're discussing. So the gradient of f2 is going to be 1 minus 2y minus 2z, right? df dx, df dy, df dz, df dx, df dy, df dz. It's a vector. When we evaluate it at the particular point in question, we end up with 1 minus 2 and 12. And again, I sure hope that you check my arithmetic here, because arithmetic is, well, arithmetic is arithmetic. I mean, it's important for the sake of computation, but it's the math that's important. We want to understand what's going on underneath. Okay, now we know that the cosine of theta happens to be, remember, vector A, the cosine between two vectors, A and B, is the dot product of those vectors divided by the norms of the vectors, the product of the norms of those vectors. So that's our standard. So what we have is the gradient of f1 dotted with the gradient of f2 divided by the norm of the gradient of f1 times the norm of the gradient of f2. Wow, look at all that crazy notation. Okay, so the gradient of f1 dotted with the gradient of f2 is just this dotted with that. So we get minus 2. 2 times minus 2 is minus 4. 12 times minus 12 is minus 144. Okay, and then the norm of this thing, if you do it, it's going to equal 4 plus 4 plus 144, so it's going to be radical 152. And here we're going to have 1 plus 4 plus 144. This is radical 149. So we end up with cosine of theta is equal to minus 150 over, and when I actually do that, it's going to be minus 150.5 equals 0.9967, which is what we wanted. And if you want theta itself, it's going to be 4.67 degrees. There you go. And again, hopefully I did my arithmetic correct, but ultimately arithmetic is not the real issue. We want to understand the mathematics. In this particular case, we have two surfaces that are intersecting. We want to find the angle of that intersection where they happen to intersect at a given point. Well, we find the vector that's normal to one surface, which is the gradient vector at that point. We find the normal to the other surface, which is the gradient vector of that surface at that point. And then we go ahead and just treat those vectors. We do our normal a dot b over norm of a, norm of b. That gives us the cosine of the angle between them. Hopefully these examples have helped to, again, just develop a little bit more of the sense of the kind of problems that you're looking at. There's only a handful of techniques at your disposal at this point, but we want to get good and comfortable with this notion of gradient and tangent plane, tangent line, surfaces, things like that, because these are our basic tools, and the fundamental tools are the ones that actually end up showing up over and over and over again. You've done enough mathematics at this point to realize that some of the higher end techniques don't always show up. It's the fundamental techniques, the things that you learn in the beginning, that end up showing up over and over and over again. So thank you for joining us here at Educator.com, and we'll see you next time for a discussion of directional derivative. Take care. Bye.